Welcome to LearnComputerScienceOnline.com. And in this video, we are going to discuss one of the most important topic in the database management system, that is, what are database keys, and different types of database keys used in the database design. The database keys are used to define and establish the relationship between the tables during the database normalization. And therefore, the students studying the database management system, DBMS, must have a good understanding of the database keys. In this tutorial, you will learn what is a database key in DBMS, different types of keys, and how these keys are defined and used during the database design stage. This tutorial will also help you understand some important related topics, such as table structure, primary key, foreign key, candidate key, composite key, and other related topics. So, let us first start with a brief introduction to the relational database. The concept of database key is related to the relational database model. The relational database model was invented and proposed by British computer scientist E.F. Codd. He also proposed the concept of database normalization. The database key is an important feature of the relational database. In a relational database, the logical structure of the database is viewed as number of interrelated tables. The database designers use the database keys to define and establish the relationship between the tables during the database normalization process. Before we start the discussion on the various database keys used in the DBMS, let us first understand the problem of data redundancy and how database normalization can fix this problem. The presence of duplication of data in the database tables is the root cause of many potential problems for the database designers. The duplicate in tables creates the problem of various database anomalies. The database anomalies, in turn, create a problem of the inconsistent state of the database. The inconsistency of the database contains data that is conflicting, and this gives inaccurate results of the database queries and other database operations. The database normalization provides solution to all these problems caused due to the data redundancy. And therefore, the database normalization is an important step during the database design process. Finding the database keys for each table is another important step that helps the database designers during the normalization process. So far we have discussed what is the significance of database keys in the database management system. Let us now understand what are database keys. In the database management system, the database key is defined as either a single attribute or a group of attributes that can uniquely identify each record in the database table. In the table structure, the intersection O(F) the table column and a table row is called as data field. Each data field holds specific data element pertaining to that particular entity. Each data field in the table can be accessed with reference to the respective column and a row. In a relational table, each table column has a unique attribute name. However, unlike the column name, each table row does not have a unique row name. And therefore, we need to define a database key that has unique value for each record in the table so that we can access each data field in a table. The database key is essential for each table. The database key will help us uniquely identify each record in the table. So far we have discussed what are database keys and its importance in the database normalization. Let us now discuss different types of database keys used in the database management system, DBMS. The database table can have only one database key. However, in order to arrive at the final choice for database key, the database designer has to explore and identify different types of keys. The relational model makes use of different types of database keys in order to define and establish the relationship between the various tables. The database types can be broadly grouped into two groups. The first group of keys include unique keys, and the second group is non-unique keys. A database key is said to be unique when it has a unique value for each row. A row is also alternately referred as a tuple or a record, or an instance. A database key is said to be non-unique when a unique key of one table is used in another table with non-unique value for the purpose of defining the relationship between the two tables. The different types of database keys used in relational model include superkey, candidate key, composite key, primary key, foreign key, and, finally, a surrogate key. Let us now understand what is superkey. The term superkey is defined as either a single attribute or a group of attribute that can be used to uniquely identify each record in a table. The superkey is the most general form of unique key. The table can have many superkeys. A set of superkeys is usually a superset for other keys. In the context of database design, the database designers will first identify number of superkey options available in a relation for a given functional dependencies. After the superkey options are identified, the next step is to identify the set of candidate keys, and then select the primary key from the set of candidate keys. In other words, a primary key is always a candidate key, and also a superkey, but the reverse is not true. Let us now understand the concept of superkey with one simple example. We will now identify the superkey options for the following student table. This example student table has 3 columns and 4 records, that is 1 record for each student. In this table, we have 6 options present as a superkey. This student table has following number of superkeys that can uniquely identify each record in the student table. The first option for the superkey is single column, student ID. The second option for the superkey is single column, student SSN. The third option for the superkey is 2 columns together. That is, student ID and student SSN. The fourth option for the superkey is 2 columns together. That is, student ID and student name. The fifth option for the superkey is 2 columns together. That is, student SSN and student name. And finally, the sixth option for the superkey is 3 columns together. That is a composite key from student ID and student SSN and the student name attribute. All these superkey options can uniquely identify each record in this example student table. In this example, the student name attribute cannot be considered for a superkey option because its unique values cannot be guaranteed. For example, the student table can have many students with the name Peter. The next step now is to identify the candidate keys from the set of superkeys. The term candidate key is defined as a superkey with minimum number of attributes. In other words, we can also define a candidate key as a superkey without any redundant attribute. The main purpose of the candidate key is to offer multiple options to the database designers so that suitable primary key can be selected. The candidate keys are selected from set of superkeys with minimum number of attributes. Each candidate key can effectively function as a primary key, but the database designers must select only one of the candidate key as a primary key. In other words, we can say that a primary key is always a candidate key and also a superkey, but each candidate key need not be a primary key. Similarly, each candidate key is a super key, but each super key need not be a candidate key. Let us now understand the concept of candidate key with one simple example. We will use the same student table example. Let us now identify the candidate key from the set of super keys for the following student table. We have earlier already identified the 6 super key options. Out of these 6 super keys, now we need to identify the candidate key options that has minimum attributes. And therefore, following 2 super keys satisfy the criterion to qualify for the candidate key. The first option for the candidate key is single column student ID. Similarly, the second option for the candidate key is single column student SSN. The remaining 4 super key options do not qualify to be a candidate key because both student ID and student SSN individually qualify to be a proper subset of these composite key options. Let us now understand the concept of primary key with one simple example. The term primary key is defined as a database key that is finally selected by the database designer as a primary key. Each table can have only one primary key. Now, we have 2 candidate keys options. That is student ID and student SSN as a candidate key option. And therefore, the database designer can now select any one of these candidate keys as a primary key for the table. The main purpose of the primary key is to uniquely identify each row in a relational table. The primary key, with its unique value for each row, is used to access each data field in a table with reference to the respective primary key attribute and the column name. Let us now understand the concept of foreign key with one simple example. When the primary key of one table that is called a parent table is included as a non-unique attribute into another table that called as child table, then such database key is referred as a foreign key. The main purpose of the foreign key is to define and establish the relationship between the 2 tables. The foreign key constraint is an important feature of the relational database design used to enforce a referential integrity. The referential integrity ensures that, for every foreign key field in the child table, there must be a corresponding table with same attribute as a primary key. The referential integrity plays an important role in the relational database in order to ensure the accuracy and the consistency of data. Let us now understand what is a composite key. The composite key is defined as a database key that consists of more than one prime attribute. The database designer uses the composite key option when a single attribute database key option is not available. In such cases, the composite key option is used as a database key. Let us now understand what is a surrogate key. In order to understand the concept of surrogate key, we need to first understand the concept of a natural key. A natural key is defined using the existing attributes present in the database table, and the redundant attribute is not added to the table for the purpose of defining a primary key. In other words, the attributes that are part of the natural key have contextual meaning that can be related to any business entity for which the database is being developed. On the contrary, a surrogate key is not a natural key because surrogate key attribute is specifically added to the table as a prime attribute for the purpose of defining the primary key. The most common and frequently used example of the surrogate key is the auto-generated integer values in the increasing sequential order, such as 1, 2, 3, 4, 5, as a primary key. That brings us to the end of this tutorial. Please read the detailed article on our website, learncomputerscienceonline.com, for more details. and in this tutorial, we have discussed in detail what are database keys, different types of database keys in DBMS, its significance in the database normalization. If you have liked this video, then please give us a thumbs up. And do consider to subscribe to this channel for more such interesting videos. Thanks for watching, and I will see you soon with another computer science tutorial video.